Okay, so now we're back to the big fraction. Not really that big, but in any case, so we've got 2/3 plus 11 over 100. So there's the naive way, which I just mentioned, where we're going to take this fraction and we're going to multiply it by 1, but it's going to be using this number. So it's going to be, we're going to multiply it by 100 over 100, okay? Because 100 over 100 is 1. So let's see if I can do this here. Times, and then I'll change this to 100 and that to 100, okay? And then over here, we'll just use this denominator, okay? So we'll multiply this one, and then let me just shrink this down again. Let's do 54. There we go. Okay, so this is the original problem, and all I've done by multiplying this side, 3 over 3 is 1. So, but what I'm going to do is I'm going to make this denominator, this 100, equal to this denominator, this 3. And all I've done is I'm doing it the naive way, but I'm saying 3 times 100. So that's the common, what they call the LCM, or the least common multiple, right? I don't know if you've heard that term before, but basically that's the smallest multiple that's shared by 3 and 100. I don't actually know if that's the least common multiple. There might be a smaller one, like, well, actually that might be the least common multiple. But that's a guaranteed way to make sure that this one and this one are equal, is just to multiply them. Okay, so let's go ahead and do the multiplication then. So this is going to be 100 times 2 is 200. 100 times 3 is 300. And then I can get rid of this. And then let's do this side now. So 11 times 3 is 33. And then 100 times 3 better be the same denominator, so it's going to be 300. And then I can get rid of this. And so there's the new problem. And so now the denominators are equal, so I can just straight add the denominators, or just transfer the denominator. So because the denominators are the same and I'm adding, not multiplying, it's going to be the same denominator. And then I'm just going to add the numerators. And so here we get 233. Okay? And so that's, I think 233 is also prime. Let's see. Let me see. It's not even. Doesn't look like it's divisible by 3. I think that's probably as simplified as we're going to get. Trying to see if there's anything else we can divide that by. I don't see anything we can divide it by. Yeah, not really. Yeah, I can't think of anything. Alright, so that's that one. So let's see. Oh, here's one. Let's do this one over here. Let's do 2/3 and then 8/12. 8/12. Okay. So now, the reason I want to do this one is, minus 8/12. Okay. So the reason I want to do this one is because you know how I mentioned that you could just multiply these two denominators? Well, don't always try that right away, because in this case you can see that actually if I just multiply this one 3 by 4, then I get 12. So I don't have to multiply them together to get 36 and use 36 as the common denominator. So instead I'm just going to multiply this one fraction right over here by 4 over 4, right? So basically 4 divided by 4 is 1 still, right? So I'm not really changing this fraction. But if I do this multiplication, then the denominator, 4 times 3, is going to be 12, and the numerator, 4 times 2, is going to be 8. And actually, so now you can see the denominators are equal, and so now I can get rid of this side. But now you're going to see, oh man, that's actually 0. So kind of a trick question. But now you can see that that's how that would work out. So you don't always, I guess the point of that one is that you don't always have to just multiply the denominators together. You can check to see if there's an easier way to get them to be equal. Let's do one more. Let's do this one right over here. 5/8, and then plus 1/4, and then let me reset this guy. Okay, so we've got 5/8 plus 1/4. Well, one way, the naive way to get the denominators to be equal would be 8 times 4 is 32, so we're going to multiply this fraction by 4 over 4 and this fraction by 8 over 8, but it looks like there's a simpler way. I know that 4 can just multiply by 2 to get 8, so actually I'm just going to multiply this fraction by 2 over 2. Okay, 2 over 2 is 1, so I'm not really changing the fraction. And so then I'll multiply 1 by 2 and get 2, and 4 by 2 to get 8, and now I can get rid of this. And so 2 over 8 is still 1/4, right? If I divide this by 2 and this by 2, I'm going to get 1/4. So 2 over 8 is the same as 1/4, but now the denominators are equal, and so I can add them. So the denominator, when I'm adding, is going to be the same. And the numerator, 5 plus 2, is 7. And 7/8 is our answer. Okay? So don't be too scared by these big numbers. So this 71 over 100, don't worry about it too much, because the other one is 2 over 5. And if you see that 5 can be multiplied by 20 to get 100, you know that you can take this fraction and multiply it by 20 over 20, which is 1, and then you'll be able to add them together. All right, and that's it.